So we're going to do a set of problems here where we're going to use logs to solve exponents. So the idea is that you're going to see anything in an exponent, you're going to turn it into a log. You're going to see anything in a log, and you're going to turn it into an exponent. So the basic strategy for this one is you want to get the exponent, the exponential expression really is the best way to say it, by itself. This is kind of along that whole isolate and destroy thing. You want to get it off by itself, then you can take care of it. I can spell. Alright, you want to get the exponential by itself. You want to take the log or the natural log of both sides. And just so you know, your book is going to focus on doing the natural log, so that's what we're going to use most of the time. It doesn't really matter. Just like you can take the square of both sides, you can take the square root of both sides, or add 5 to both sides, or divide both sides by 2. You can, as long as you do the same thing to both sides of the equation, you're pretty much home free. So we're going to take the log of both sides of the equation. You're actually going to use the power rule to simplify. Power rule. I can spell. To simplify. And then you're actually going to go ahead and solve for x, or whatever it is you're looking for. So, for example, I have a problem like 4 to the x equals 15, right? Well, the 4 to the x is the exponent, it's all by itself. So I'm going to come in here, and I'm going to take the natural log of both sides. I can use the power rule now to simplify and say that that's x, natural log of 4, equals natural log of 15. So what's important to recognize when you're doing these is that natural log of 4 is just a number, right? If I go stick it in my calculator, I can get natural log of 4 and get something. It's just a number. It's nothing, it's not a variable, it's an actual number. Natural log of 15 is just a number. So if you think about it, if I gave you, x times 4 equals 15, and asked you to solve for x, you'd say, oh, no big deal, I'm just going to divide both sides by 4, and I'll get my answer that way. Well, this is the same kind of thing here. You have a number, natural log of 4 times x, equals to another number, natural log of 15. So what you can do now is you can divide both sides by natural log of 4. Now, please don't do the thing where you're like, oh, look, the natural logs cancel out. They don't cancel out. This is a whole number by itself. Natural log is an entirety, all encompassed in itself. Natural log of 4 is a number. So I have a number divided by another number. This number in its entirety cancels out with this number in its entirety. It would be equivalent to doing something like this. If you just tried to cancel out the logs, say I had, 15 over 17. If you're like, oh, look, the ones cancel out, so that gives me 5 over 7. That doesn't make any sense. So for the same reason that doesn't make sense, it doesn't make sense to cancel out the natural logs. So we've got now x equals natural log of 15 divided by natural log of 4. Believe it or not, that's the answer that your homework's looking for. It's going to ask you for this answer, it's going to ask for the exact answer, and then it's going to ask for the number answer. So for this, really, all you need to do is just go plug this in. Natural log of 15 divided by natural log of 4. And you've got 1.9534. So 1.9534, like that. So let's work a couple more. Say we've got e to the 3 plus 4x equals 512. All right, we've got the exponent by itself off to one side, and everything else is on the other side. So let's go ahead and take the natural log of both sides. Natural log of both sides. I'm going to use the power rule to simplify. Now when I pull that exponent out front, I want to be careful to pull the entire exponent out front. And then write natural log of e. If you're really on the ball, you'll recognize that what's going on here is actually a property, a logarithm property. You can pull the exponent out directly. But if you just want to go ahead and use the power rule because your brain hurts, that's completely legitimate. So I've got 3 plus 4x, and I won't think that you'll recognize now that the natural log of e is equivalent to 1, so times 1, so I really don't even need the parentheses anymore. That's just 1, so that goes away, equals natural log of 512. I'll go in here and subtract 3 on both sides, because now I'm just looking to isolate the 4x. So I've got natural log of 512 minus 3. Divide both sides by 4, and I get x equals natural log 512 minus 3 over 4. So that's one answer. Now you'll need to plug it in your calculator, and make sure you do this really carefully. Your parentheses are going to bite you if you don't get them right. So what you want to do is recognize I have to put the entire top in parentheses, so it's going to look like this. Minus 3, that whole thing divided by 4. Because if you don't put the parentheses, it's going to do this. If you just say this, what you're really getting is equivalent to natural log of 512 minus 3 over 4. And that's not what you want. You don't want just the 3 divided by the 4. You want the entire thing divided by the 4. So that's why you have to put the parentheses there. So natural log of 512 minus 3 divided by 4 gives me 0.8095, so 0.810. So this is equal to about 0.810. So these problems at this level aren't too aren't too long. They're not too bad, but they can get there really quickly, and I'll show you that in a minute. Let's try another one. Say we've got 40e to the 0.6x minus 3 equals 237. Now we can't just go crazy and start taking the log of both sides, right? Because we have to isolate the exponential. So go ahead and move our 3 over. Now this still isn't good enough. I need to get the e to the 0.6x all by itself, so I have to get rid of that 40. So I'll divide both sides by 40. So I've got e to the 0.6x equals 6. Now I'm ready to go. E to the 0.6x. I'm going to go ahead and take the natural log of both sides. And I can write my power rule. Again, if you're kind of thinking quick on your feet, you might go ahead and recognize that that's 1. So you can write this directly as 0.6x equals natural log of x. So if I divide both sides by 0.6, I'll get x equals natural log of 6 over 0.6. So natural log of 6 divided by 0.6. So 2.986, or about 2.986. Alrighty, let's try this one. So we've got 10 to the x equals 120,000. Now this is an example where, since we have a base 10 exponent here, rather than using a natural log, let's go ahead and use a base 10 log, because we have that button on our calculator too. And if you'll remember in our instructions up here somewhere, it said we could take the natural log, the common log or the natural log. So let's go ahead and take the common log of both sides here. So log base 10 of 10 to the x is x. Again, you can pull the exponent out front and simplify it, but you're going to end up with x one way or the other. And now x is log of 120,000. And this is a really short problem because you just go log 120,000 and say thank you, 5.079. So about 5.079. like that.